It's Mr. Bruder. Today I'm going to take a look at how to do some computational fluid dynamics on Solidworks CFM. So what I have is I've created a couple of different files here just to show you what's going on. I'm going to start off with a really simple one. This is just going to be a simple pipe that's going to have some fluid flowing through it, and it's going to be coming out of a nozzle here. So you can go ahead and create anything that you want. Start off really simple just to get the feel of this, and then you can start to get things a little bit more complicated. So the very first thing that we're going to have to do is we're going to have to save this. So just go ahead and hit the Control S, and you can do a file name. You can see pipeflow1 is what I've created here. Now the next thing that we're going to do is, to make this easier to see, is that regardless of what you're actually going to be making it out of, we're going to actually turn this into glass material. That's going to give us our transparency so we can see our arrows and see the actual fluid dynamics. The way that we can do that is two different ways. The easiest way is going to be going over here. The second way is up and over here for the display manager, but we're going to click on this. You're going to get a whole bunch of different drop-down menus for your appearance color. So we're going to find glass. If you just click on the top folder, you'll see that we have a couple of different choices here. And then just click and drag and place it anywhere on your part. Now you have options to do a face, the sweep, the body, or the whole entire part here. So in our case, these two are the same. I'm just going to pick the whole entire part. And now we can see the translucency or transparency that this glass has provided us. So now that we have our model prepped, we can start to get into the actual CFM simulation. So unlike our linear analysis, which we could do in the Simulations tab, we actually have to go to our SolidWorks add-ins, and then we're going to click on the SolidWorks Flow Simulation. When we click on that, we're going to get an extra tab for Flow Simulation. So once you have that, we can click in here, and we'll get a whole new menu set up top. Now, in order to do any type of internal fluid, so we're doing this in a pipe, we need a completely closed system. The way that we close our system is we use this lid feature here. We can do this manually, but this is by far the easiest. By simply clicking on that, it's going to ask us to create the lids, so we can click on this face here. You can see our blue lid is created, and then we can also click on the face at the bottom. That is also going to create a lid there. Checkbox. You can see our lids are created at the bottom of our whole entire features list. And now we are ready to go and actually do some CFM. So to get started, the wizard is by far the easiest way. A lot of this stuff you can get into some really complicated things, but I'm going to go through this relatively quickly, and it's going to be relatively simple. So we can skip to the next one. You can select your units, whatever you want those to be. And then this is where you can choose internal or external and add some extra parameters, for instance, gravity, rotation, if you're doing a rotation one, which I'll do a video on in the future, but we're keeping this very, very simple. Next, we have to apply what kind of liquid or fluid is going through this. So you can see there's a whole slew of things here. In this case, we're going to be doing a liquid, and we're going to be doing water. And you'll notice that it's already pre-selected for us, and then once we have our liquid selected, we click the add, and it'll apply it to what our actual model that we're testing. We can hit next. We do not have to worry about the wall thickness and the interaction there. This is just stating all of our pressures and temperatures, so basically it's normal sea level temperature. And now we are ready to go. You can see we've created the bounding box, which is going to be our computational domain, the fluid domain here. And if that's in the way or you don't like it, you can simply right click and hide that. So it won't make a difference one way or another. Now to get started on this, you really just need to do two things. We need to add where the water's coming in and then where the water's going out. So we add that by setting boundary conditions. We right click, insert a boundary condition. The first thing that we have to do is we have to access or click on the inside face of the cap. Now you can see as I start to move around, all of the outside faces get selected. So this is when we can right click, select other, and you'll see that you can actually get the back side of that cap. That's really important. And then we can set this to be the inlet, and we can, or the outlet, but for our purposes it's going to be the inlet. And we're going to just do inlet, let's go velocity. So we're going to be able to set the velocity of the fluid coming into this, and we'll see the velocity going out. We're going to keep it really small. We're just going to keep it at 3 meters per second here, and we can hit the OK button. Now you can see the arrows are specifying the direction of our fluid flow, and we need to now tell it where it can come out. So we set another boundary condition, insert the condition, zoom in, right click, select other, get that face in the back there. You can see we've got it. And now instead of doing an outlet, which could actually have conflicting things because you're pulling fluid out, which might be something that you're doing, but you're also pushing fluid in, we're just going to set this as a nozzle, and we're going to change this to a pressure opening. And we're going to leave it right at environmental pressure and hit OK, meaning that there's only the environment pushing back on this. There's nothing pulling it or pushing it in any extraordinary way, and it's going to allow us to see this the best way possible. Now that we have those two boundary conditions set, we can go ahead and hit our run. We're going to set this to use all the CPUs on this computer and click run. Now you're going to pop up with this. It's going to prepare the model on the mesh, and it's going to go through some iterations. Depending on the complexity, this is where it could take a little bit of time, and it's going to calculate all the different iterations. Keep an eye and make sure that there's no warnings. I've gotten this when I've been playing around where my fluids have actually been going supersonic, which you would want to set something special for that. And then you can also make sure that this is just kind of doing what it's supposed to be doing. Now when this actually finishes, nothing is going to change. You'll see this in a second, but we're going to be able to set up our results to actually see what's going on. So now the solver is finished. We can X out. You can see nothing really looks any different here. But next to your results, you should see something in parentheses here. And now we can start to actually add results. So this is where the fluid dynamics really kind of shines. We pop this open, and we can do a couple of different things depending on what we want to do. I prefer using the flow trajectories or the cut plot. And we can use these simultaneous. So first, the flow trajectories, we're going to insert that. And essentially what this is going to do is this is like putting a particle into the flow stream and watching where it goes. So we're actually going to be putting 20 particles in this case, 20 points. And we're going to make them pipes. I'm going to actually change that, but we have to tell it where to start. So our starting point, we have our box selected. Again, right click, select others, get that back face. Now on a smaller thing like this, the pipes are a little heavy, so I like to go with lines and arrows. We can leave everything to default, and we can actually leave this as pressure, or we can change it to anything. So let's take a look at the velocity and hit the OK button. It's going to run. You can see your fluid flow, and you can see how your pressure changes. So as your velocity changes. So as the fluid comes around and gets closer to the nozzle, it actually increases in velocity. It's exactly what we would imagine. Now, if you want, you can simply change this by clicking on your values here, and you can pick whatever you want. So pressure, checkbox. Now it re-updates, and you can see how the pressures are actually decreasing as the fluid is exiting the nozzle. So since this nozzle is small, this whole entire system is under pressure, and then it depressurizes as it goes out. And finally, if you wanted to, we can take a look at this, and you can actually see that the temperature is the same thing. You're under compression here, so you're actually increasing the fluid temperature, and then as it decompresses, it goes forward. Now, this can also work in conjunction with the cut plot. A cut plot is kind of like the fluid flow, but it kind of gives you a better snapshot of what's going on. So a cut plot works on a plane. So you can see right now we're selecting the front plane. I don't want that. I'd rather go through the whole entire thing. So I'm going to select and change my planes, and I'm going to take a look at what plane I want. And it looks like the YZ plane is going to go right through everything. I'm going to leave it as contours. Feel free to change it however you see fit. Since I already have velocity, I'm actually going to change my measures to pressure and hit the OK. And you'll see that it puts this whole entire piece in the background. So if I right click and hide my flows, you can see that this is the pressure in the entire vessel, and then as it gets to the end of the nozzle, it starts to actually depressurize. So now you can see everything in the whole entire area the entire time, and if we turn this back on by showing this, you can actually see the velocity and pressure and how they correlate to each other, which is kind of neat. And then finally, we're going to hide this. That's our cut plot, and we're actually going to be able to play and watch our flow with our flow trajectory. And if you're looking to create a little video or animation, this is perfect for you. And there's one more thing that we can do that actually makes this a little bit more complicated, but it's just one simple click. So we can edit our definition, where we can, instead of changing everything, all we're going to do is set this to a dynamic trajectory. So this is going to become a little bit more complicated. We're going to leave it as arrows. You can see we have a couple of other different things, velocity, everything's going to stay the same. And what it's going to do is it's going to kind of show you simultaneously everything moving through. So we have the arrows here. We also can edit this definition, and we can use spheres. And we can see how things are actually going to flow through our pipe here as they move. And then finally, again, we can stop that. We can even hide that. We can also turn on our cut plot and change this to anything that we want. All right, one more example I have here is, this is really basic, but I've prepared another one. We have our cyclone system here. So this really shows you some of the capabilities of what's going on. This would essentially be a cyclone where you have a vacuum coming out of this end, so it pulls air through. That means it's a big vacuum over here sucking air in. And then as the actual air is turbulent, heavy particles can fall to the bottom. This is pulled from an example right online, so if you want to take a look at that, there's a much more in-depth video on what they do there, actually using a particle study, which is pretty cool.